Hi everyone and welcome to another lecture. Today we'll be talking about three operations on matrices. The first one is the transpose of a matrix. Second one will be a conjugation, how we can conjugate matrices, and the third one is called a dagger operation. So let's start. The first one is what we call transpose of a matrix. So what does transpose means? Transpose means exchanging rows and columns of a matrix. Let's take an example. Let's say you have a matrix called H and it is denoted by 1, 2, 3, 0, 6, 7, and I want to find transpose of H. We denote it as H and there's a T on the superscript. So what is H of T? That is, we want to exchange these rows and columns. So to do that, this is our first row, and after you transpose it, this will become the first column. That is, for H of T, let's write it over here, and let's write it like this. This row will now become a column over here, and let's write these elements, that is 1, 2, 3. Similarly, the second row will become the second column. So this will be 0, 6, 7. This is how you can do transpose. Take another example. Let's say you have a column matrix A as 1, 0, 3. A transpose is equals to what? This is the thing we want to know. So there are 3 rows and 1 column, and the rows will become columns, right? So for AT, that means A transpose, the first column is just 1, the second column is just 0, and the third column is just 3. This is how you can do transposition of a matrix. The second thing we want to discuss is conjugation. Conjugation means that when you have a matrix called, let's say, A prime is equals to 1 plus I, let's say that's the first element, and the second element is 0, third element is, let's say, 3, fourth element is like minus I, and you want to find the conjugate of this matrix. It is denoted by A star. This means you just take the complex conjugates of the complex number that is appearing in the matrix of interest, that is A prime. So the conjugation, that is after the conjugation, we'll have A minus I, 1 minus I, this will be 0, this will be 3, and this minus I will get replaced by plus I. So from here you can see that if all the entries in the matrix A prime were just real numbers, not complex numbers, the conjugation will be the same as the initial matrix. So this is how you can conjugate a matrix. Now what we want to discuss is that the dagger operation. In fact, it has a particular name and it's called the Hermitian conjugate, but let's try to introduce the dagger notation first. Let's say you have a matrix called E as 1, 1 minus I, 3. and you want to find out what would happen after you do a dagger operation on this E matrix. So what does this dagger operation mean? That is this one. What does this mean? That is the thing we want to see first. This means you can take the conjugate of it and then transpose it, or similarly you can first transpose it and then take the conjugate of it. This is what it means. So let's do this part, that is we'll first take the conjugate and then transpose it. So after you take the conjugate, this becomes 1 plus I minus I 3, and then you have to transpose it. So after you transpose it, it's just 1 plus I minus I 3. So this is how you can take the Hermitian conjugate or dagger operation on a matrix. Let me just write this Hermitian conjugate for your convenience. The reason it's called a Hermitian conjugate because there are certain type of matrices that satisfy the following. Let's say H, and this H dagger is equals to H. This type of matrices are called Hermitian matrices, and they play a significantly important role in physics because they have real eigenvalues. Now you might find these terms a bit strange because I have not introduced them yet, but as we go along this course you will be introduced to them. And the punchline about these Hermitian matrices is that they correspond to some observables. That means something that you can measure about a physical system of interest. So this will be it for today, and thank you. I will see you guys on the next lecture.